Hi, this video is going to talk about different ways that we can charge up an item. There are basically three different methods of charging, okay? You can charge an object by rubbing an object with another object, okay? You can charge an object via contact. This works especially well when the objects are conductive. And the third way that you can charge an object is by induction. Induction is the one that's a little bit difficult to understand, so you might want to watch that section of the video twice. Okay, first off, charge by rubbing, okay? Whenever we rub one material against another, there's a chance that one material will give up electrons to the other, okay? The object that receives electrons will become negatively charged, and the object that gives up the electrons becomes positively charged. It's important to realize that this is a zero-sum game because of conservation of charge. Charge is not being created here, it's just being transferred from one object to the other. Although it is possible to determine which object gives up the electrons and which object receives electrons, okay, that's what the triboelectric scale on the right here is. You do not need to know this. It's not something that we focus on. It's just important for you to realize that it is possible. Okay, so for instance, if you look on the scale to the right, human hair tends to give up electrons very easily. Therefore, it's more positive, okay? So it gives up the electrons, and when you're brushing your hair with like a plastic comb, plastic is something like PVC or polyurethane. Those are plastics, okay? And so those become more negative. They're on the bottom of the scale. They receive electrons very easily, okay? Charge by contact is also pretty straightforward, okay? Whenever I have two conducting objects, okay, one object can share its charge with the other object, okay? Again, this is a zero-sum game, okay? There's conservation of charge that's occurring in this situation. For example, on the left object, okay, left sphere, I have a charge of minus 4q, okay? Doesn't really matter what q is, it's just a constant of some sort or another. Okay, the right object is negatively charged. Okay, the net charge between both of these is minus 4q. Okay, as long as this is a closed system, that's never going to change. Okay, so charging by contact though requires me to touch the two objects together. The two objects must touch. Okay, so when those two objects touch, okay, all the negative charges that were on the left sphere, okay, remember, negative charges repel each other. And the instant I touch them, as long as they're conductive, those charges want to get as far away from each other as they can. And so when they touch the other sphere, they realize they have a lot more space over there. So half of the charge goes over to the other side. Okay, and the other half of the charge says, well, if you're going there, I'm staying here. Okay, so we end up with this sharing of charge. Okay, but during this entire process, the net charge doesn't change. Okay, so then when I then separate the two charges, those charges can't get back to where they were. Okay, instead, that total charge of minus 4q gets evenly distributed between these two. Okay, so I have minus 2q on the left object and minus 2q on the right object, okay? And they really can't come back together unless something else changes. Okay, that brings us to charge by induction. Okay, a key aspect of charge by induction is that the charged object does not touch the uncharged object. Okay, this is not a closed system, so we can't quite analyze it from a conservation of charge view. Okay, instead, there's a source, okay, or a sink for electrons to travel from or to. Okay, so this is an indication of charge by induction. I have a neutral sphere here, okay, but I have this little grounding wire, okay, that's a wire attached to the sphere or something that acts as a ground, okay. Ground, that little upside down pyramid looking thing, is a symbol for ground. It basically means that this is an infinite source of electrons or an infinite source to send electrons to. Okay, and so that's what grounding is. You can accomplish the same thing effectively, at least for the size of the charges that we're talking about, with basically just touching it with your finger. Okay, and you may have seen this demonstration done in my classroom. Okay, so but charging by induction requires me to bring a charged object close, but not touching. Okay, remember, that's a key aspect of charge by induction. I bring it close, but it doesn't touch. Okay, and the whole point of bringing that charged object, in this case, my charged object happens to be negatively charged. Okay, and because it's negatively charged, it repels the electrons, or at least it repels some of the electrons in my neutrally charged sphere. Okay, and since the electrons have somewhere to go as far away from that charged rod as possible, basically they go in down the wire into the ground. Okay, so those electrons disappear. And then the next step out of this is to basically remove that grounding wire. Okay, remove what's ever touching. And therefore, the electrons have been isolated. They can't get back in. And since my sphere gave up the electrons, okay, it's now left positively or opposite charge to the to my negatively charged rod. So just to summarize the steps associated with charging by induction, okay, the first step is I need to bring a charged object near, again, not touching, but near an uncharged object. By bringing it near, I'm repelling the same charges. Whatever charge my object A has, positive or negative, it repels the positives or negatives in object B. Okay, and object B, by grounding it, I basically allow those charges to go somewhere else. Okay, and so if it's repelling electrons, the electrons go down through the wire into the ground. Okay, if it's a positively charged object A, okay, you can think of it as repelling the protons, but in reality, it's attracting electrons from the ground up. Okay, so then step 3 is basically I have to remove the grounding wire or the grounding finger. Okay, and by removing it while object A is still there, it basically isolates object B so that the charges can't return to wherever they came from. Okay, step 4, I remove the charged object A, and now object B is oppositely charged to object A. Okay, and while in this situation, while you can think of the positively charged particles leaving object B and going into the ground, okay, that model works because it leaves object B potentially negatively charged. If I removed positive charges, I'm left with negatives. Okay, but you need to remember that it is always the electrons that are moving, okay? The protons are locked into place in the nucleus. So if object A happens to be positively charged, okay, what it's actually doing is it's attracting electrons from the ground or your finger or whatever is touching object B, okay? So you can think of it as the positive charges moving, but in reality, it's always negative charges either leaving object B or entering object B. Okay, and then the other thing to remember about this, okay, the object is now charged opposite, okay, to whatever object B is now charged opposite sign to whatever object A was. Thank you.